Alright, so in this video I'm going to do a follow-up on the video that I did before, in which I was supposed to sketch this graph. Now in the previous video, what I did, I completed a square on this question, and I was supposed to sketch the graph pertaining to what we had. So I'm going to go ahead and continue with the question. So with the question, they said we're supposed to sketch the graph of y equal to 3x squared minus 12x plus 8, showing on your sketch the intercept on the y-axis, the coordinates of the minimum point. But what I'm going to do, I'm going to sketch the graph. I'm going to sketch the graph, and I'm going to show the roots. And we know that roots are x values. The x values where the graph cut the x-axis. So I'm going to draw a little rough sketch and show you what I'm referring to when I'm talking about these pointers. The second thing I'm going to show the y-intercept. The y-intercept is where the graph cuts the y-axis. I'm going to be showing after I show the roots, the y-intercept, I'm going to be showing the axis of symmetry. I'm going to be drawing that line, and I'm going to be labeling all of those points on the graph. I'm going to be also showing the coordinate. I'm going to also be showing the coordinates of the minimum or maximum point of min or max point. Okay, so if you have a positive quadratic graph, for example, if we had like f of x equal to ax squared plus bx plus c, we know that the coefficient on the x squared is going to determine whether or not the graph is a smiley face or if it's a n-looking graph. So if it's positive, it's going to look like a smiley face. So the graph could look like this, smiley face. So this would be the x-axis, this would be the y-axis. So this point right here, where the graph cut the x-axis, this point right here, this could be considered to be a root, in which x is equal to a. A represents a number, positive number. Right here is another root, where x would be equal to, let's say, minus b, because this is on the negative side of the x-axis. So this is a root, this would be a root. Remember, roots are where the graph cuts the x-axis. Also, the y-intercept is where the graph cut which axis? The y-axis. So right here, this would be the y-intercept, where we would have let's say right here, the coordinate right here would be 0, comma let's say c, or yeah, c, because the y-intercept is the c value. So the coordinate right here would be 0, c. Right here, the coordinates for where the graph cut the x-axis could be a, comma 0, because on the x-axis, y is equal to 0. This is another name for the y-axis, for the x-axis, sorry. Another name for the y-axis could be x equal to 0. So this is the root, this is another root, this is the y-intercept. This line, which bisects the graph, is known as the axis of symmetry. And we know that it's a x value, so x would be equal to, let's say, k No, not k, because I don't want to confuse with the all completeness square stuff. So let's say this is m. I'm going to put m. So this is the line that represents the axis of symmetry. Now the minimum point on the graph right here, remember the f of x value would be the y value right here, and the coordinate for the minimum point, coordinate would have, remember that the minimum point for f of x is the k value when you complete the square, and if they ask for the coordinate, you would have to combine it with the x value that represents the axis of symmetry, which is m. So the coordinate for the minimum point would be m, which represents the axis of symmetry, and the k, which represents the minimum point for f of x. Remember, f of x would be equal to k, which is the minimum point on the graph, the f of x value. So this is how you would sketch a positive quadratic. Now the negative quadratic, it would be in the form, let's say it's g of x equal to minus ax squared plus bx plus c. So I'm just drawing some representations of each graph before I look at the question. So sketching this graph, it would look like, let's say it would look something like this. So remember, with this graph, we would have a minimum point down here. With this one, it would have a maximum point right here. Would be a max point, a max point for f of x. Right here would be a root. Right here would be another root. Down here would be the axis of symmetry. Right here would be the y-intercept. So basically it's the same features, it's just that the graph will be turned upside down. So when this one is, when the graph is positive, it looks like a smiley face. When it's negative, it looks like an N. So those are the points in which, if you're going to sketch a graph, it's supposed to show. So as I said, I'm going to go back to the question. So what I'm going to do, I'm going to redo this question. So I have 3x squared minus 12x plus 8. Remember, we were supposed to express it in the form of a bracket x plus h all squared plus k, where h is equal to b all over 2a, k is equal to 4ac minus b squared all over 4a. So all we need to know, or all we need to remember, is that this is in the quadratic form. The general form for quadratic expression or equation, it's in the form of ax squared plus bx plus c, what I did in the previous video. So we know that a would be equal to 3, b would be equal to negative 12, and c would be equal to 8. So all we need to do is to put these values into both formula to calculate h and k. So for h, remember, I calculated the values in the previous video. So h would be equal to negative 2, k would be equal to negative 4. So that would be h. This would be h, this would be k. So we just express it in this form. So we know that a is 3. So we would have 3 bracket x minus 2 all squared plus k. But remember, k is what? K is negative 4. So this would be our answer. Now, I'm going to do the follow-up question in which we're supposed to sketch this graph. But instead of showing only these 2 points, I'm going to show you all of the possible points that they could ask you to show. So they could ask you to show the roots, the y-intercept, the maximum point, or the coordinates or stuff like that. So I'm going to be showing you all of these stuff while I'm sketching this graph. Now, while sketching the graph, the first thing you need to check to see if the question can be factorized. You need to do that. Because if the question cannot be factorized, we are going to use the quadratic formula. But if it can be factorized, we have an easier way. Remember, the quadratic formula the quadratic formula x equal to minus b plus or minus the square root of b squared minus 4ac. You use over 4ac minus b squared minus 4ac over 2a. We use this formula to calculate roots of a quadratic function, whether it can be factorized or not. But if the function can be factorized, it's much simpler. Well, to me, it's much simpler, because if you factorize this equal to 0, you're going to get the well, if it can be factorized, you're going to get the product of two binomials. So for example, you'd have x minus a times x minus, let's say, b, and if it's equal to 0, all we do, this is the product of two binomials, so that each of the binomials equal to 0 and solve for a. Solve for x. So x would be equal to a here, and x would be equal to b here. So what you need to do first, check to see if the function can be factorized. So that's what I'm going to do first. So I'm just going to check and see. So we have 3x squared minus 12x plus 8 equal to 0. So we have 3. Remember, we're using the AC method. Remember, you can go and check my previous videos on factorization. So 3 times positive 8 is positive 24. I need two numbers or two factors. When I multiply them, I should get positive 24. But when I add them, I should get negative 12. Now, you could check all day to see whether or not it can be factorized, and you're not going to, you cannot factorize this. So what I'm going to do, I'm going to use the quadratic formula on this, because let's see, if we use negative 2 times negative 12, that's positive 24. But if we have minus 2 minus 12, that's this. When you add these, we're going to get negative 14. Negative 14 is not negative 12. If you want, you could check two other values. We could have also used what? 6 times 4. 6 times 4 is positive 24. When we add them, 6 plus 4, we get 10. We need to get 12. So whether you put negative, positive on them, it's still, you're not going to be able to factorize this. So what I'm going to do, I'm going to use the quadratic formula. So the quadratic formula, I used the quadratic formula in the previous video, so make sure you have watched the video that I did before, and to learn how to use the quadratic formula so that you can use it properly. So we have, remember, the quadratic formula is x equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So remember, the a is equal to 3, b is equal to minus 12, and c is equal to 8. So I'm going to have x equal to minus b, the b value was negative 12, plus or minus the square root of b squared, which is negative 12 squared, minus 4 times a, which is 3, times c, which is 8, divided by 2 times 3. So as I said, you can use a calculator. So I'm just going to use my calculator here. So we know that this is positive 12 plus or minus the square root of 144, because 12 squared is 144. 3 4 is 12. 12 times 8, that's about 96. So remember, we did this already, so don't even have to use a calculator. Divided by 6. Now, x is equal to 12 plus or minus the square root. What I'm going to do, I'm going to subtract these two numbers. So 144 minus 96 equals to 48 divided by 6. Afterwards, I'm going to use my calculator to find the square root of 48. So the square root of 48 is 6.928. So I'm going to round it off to 2 decimal place. So x would be equal to 12 plus or minus 6.9. So we have 2 8. So I'm going to round it off to 2 decimal place. So it will be 9293 divided by 6. When I'm at this stage of the question, I'm going to write the the x value 2 times. So remember roots, we have two roots in this case. So x with the plus or minus, one is positive, one is negative. So I'm going to write one of the x value with the plus sign, one with the negative sign. So I'm going to have x equal to 12 plus 6.93 divided by 6, and I'm going to have x equal to 12 minus 6.93 divided by 6. So I'm just going to use my calculator and work these out. So I'm going to add these, press equal, then divide by 6. So I'm going to have 12 plus 6.93 equal 18.93. Then I'm going to divide by 6. I'm going to get, so x is equal to 3.155. Here we have x equal to, so I'm going to have 12 minus 6.93 equal to 5.07. Then I'm going to divide it by 6. Remember, add or subtract, then you divide. Equal to 0.845. So these x values would be the roots. So we have let's see. So we have the minimum value for f of x, we have the axis of symmetry, we have the roots, and remember to determine the y-intercept. The y-intercept is the c value right here, which is 8. So we have those, so we're just going to put them on our sketch. So the sketch of this graph, so I'm going to draw my axis. Draw it like this. So this is the x-axis, this is the y-axis. So the roots that I got right here, we have 3.155. So I'm going, so let's see, we have 1 here, we have 2, we have 3, we have what, 4, we don't need so much still, so 5, 6, we don't need all of these values. And here I'm going to have 1, 2, 3, 4, right up to, let's say this is 8. 5, 6, 7, 8. So let's say that is 8. We have the origin here, so the roots, I'm just going to mark my points. So for the roots, we got, I'm going to round off these numbers. I'm going to round them off to the nearest whole numbers. So let's say this one, I'm going to use x as 3, and this one, I'm going to use x as 1. So I'm going to use x as 3 here, so this is a root, which is x equal to 3. Remember, I'm rounding off the numbers to the nearest whole number. This one right here, this is another root, x equal to 1. So that's the roots. The y-intercept, this is the y-intercept right here, y-intercept. So remember, the graph is going to cut here, the graph is going to cut here and here. Now, the other points that we're supposed to put on the graph is the what? The minimum point. Remember, the minimum point for f of x. The minimum point for f of x was -4. So I'm going to have -1, -2, -3, -4. So, and the axis of symmetry, remember this is the axis of symmetry. Axis of symmetry was 2. So this line represents the axis of symmetry. So, and the coordinate for the axis of symmetry, remember, we're going to combine the axis of the value for x, which represents the axis of symmetry, and I'm going to combine it with the minimum value for f of x, which was -4. So it's right here. They're going to meet right here. So this right here would be the coordinate for the minimum point, 2, -4. So we have labeled our points. Remember, this is the minimum point, min point. So I'm just going to be sketching this graph. So I'm going to do something like this. This goes across here. This is not properly sketched, but hope it's sending in the right idea of how to do this. So this is how our graph would look as a sketch. So with the question, they said we were supposed to show what? They said we were supposed to show the intercept on the y-axis. So the intercept on the y-axis is this point, and they said we're supposed to show the coordinates of the minimum point. So this is the coordinate of the minimum point. Remember, to get the coordinate of the minimum point, we would combine the value for the axis symmetry is 2 and the minimum point for f of x. So that is how we would get the coordinates for the minimum point. So I'm going to do another question. So hopefully you're understanding what I'm doing. So I'm going to be doing another question, another past paper question, and then that would be it for completing the square. So get some extra sheets here. So with this question, we're supposed to complete the square, state the minimum value. And with this one, I'm supposed to do what? State the equation for axis of symmetry. With this one, sketch the graph, 4 marks. Alright, so I'm going to just run through this question. So the function, so I'm going to go through a bit fast. So this is 3x squared plus 6x minus 2. So the f of x is equal to this. So remember, we're supposed to express this in the form of a bracket x plus h bracket squared plus k, where h and k are real numbers. So h is equal to b over 2a. So h is equal to b, which is 6, over 2 times a, which is 3. So h is equal to 1. K is equal to 4ac minus b squared all over 4a, which is equal to 4 times 3 times minus 2 minus bracket 6 squared all over 4 times 3, which is equal to 3 4 is 12. 12 times minus 2 is minus 24, minus this is 36 divided by 12, which is equal to, so remember this is a k value. So we have negative, this is what, 60, negative 60 over 12. So we know that dividing that would give us 5, negative 5. So our answer, expressed in this form, would be 3 bracket x plus 1 all squared minus 5. So this would be our answer. This would be our answer for completing the square. So this is for 3 marks. The second part of the question, they say hence or otherwise state the minimum value of f of x equal to 3x squared plus 6x minus 2. So remember, once they refer to minimum or maximum value, they're referring to which value? They're referring to the k value. So f of x would be equal to minus 5. So this would be the minimum value or min value. That's for 1 mark. The second question, there's a state the equation of the axis of symmetry of the function of the same function. So the equation for the axis of symmetry, as I said, you're going to let this part equal to 0. So it would be x plus 1 equal to 0. This would be the equation for the axis of symmetry. Determine the value for x, which represent the axis symmetry. You just solve for x. So x would be equal to minus 1. The next part of the question, they said we were supposed to do sketch the graph showing on your sketch the intercept of on the y-axis and the coordinate of the minimum point. So what we can do a little small sketch right this region right here. So remember, let's see. So to sketch the graph, the y-intercept, we know that the y-intercept is the c value. The c value right here, this is in the form of a x squared plus bx plus c. So the c value is negative 2. So we can do a little sketch here. So we know it's going to look like a smiley face. The c value is negative 2. So we know that. So we have negative 1 here, negative 2 here. So we know that's going to cut the y-axis right here. So the y-intercept was right here. Okay. They said that they need what else? They said that they need the coordinates of the minimum point. Now, the axis of symmetry, the x value that represents the axis of symmetry, we know that this is negative 1. So negative 1 is going to fall on this side. So let's put it here, negative 1. So we know that this is the axis of symmetry. And as I said before, combining the value for the axis of symmetry and the minimum value for f of x, that would give us the coordinate for the minimum point. So we need to extend this line. So this is negative 3, negative 4, negative 5. So combining these two, come across. So this right here, this point right here, would be the minimum point on the graph. So we can just draw this, go up here. So it's supposed to go through this point right here, go through the 2 right here. So sorry about that. And we can just draw this up here. So that's basically a sketch of the graph, of how the graph is supposed to look. So this is the x-axis, this is the y-axis. They put on these stuff on the graph. They didn't ask for the roots or anything. So remember, I'm just going to do a little rough sketch again with a pen here. So remember, this is negative 1. Right here is negative 2. So the graph is supposed to cut right here. The x-axis right here. So this is the y-axis right here. So this is the y-axis. This is the x-axis. The minimum point right here. Remember, combining the axis symmetry with the minimum point for f of x would give us the coordinate for the minimum point. So the graph would look something like this. So the graph would look something like that. So remember this. So we are showing this is the minimum point, min point, and the coordinates for the min point is negative 1 and negative 5, which is right here. Remember, negative 1 and negative 5, which is a coordinate for the minimum point, and the y-intercept would be right here. The y-intercept would be c equal to negative 2. So remember, c represents the y-intercept, which is right here. C equal to negative 2. So that is how the graph would look when you sketch it. So hopefully you're understanding what I'm saying pertaining to the sketching of the graph and completing the square. So I think that's it for completing the square.